Hey guys, how's everything going? This is JSer. I saw a new post from Web.dev. It's called Optimize Long Tasks. And if you have been watching my videos, you know that I made an episode about how React scheduler work. It's on the JSer.dev. If you're interested, please take a look. And I just jump straight to the summary here. So basically, the scheduler does one thing is scheduling the tasks and prioritize them. Obviously, in React, it sets a maximum 5 milliseconds for each task to run. After that, after 5 milliseconds, it will try to yield to the main thread, which means give the scheduler to reschedule the tasks. The graphics looks a bit complex, but I think the explanation there would be straightforward. Honestly, I don't remember the details unless okay. But anyway, if you take a look at the data structure here, so this is the runtime part, and here is the scheduler part. So basically, for the runtime, it will schedule it add the task into the scheduler, and the scheduler will try to run them. And the tasks are put into a priority queue. Actually, it's implemented by min hip, and so basically, it will just take a look at the task and run it, and yeah, just to take. And when we push a new task, it will push it into the min hip, and here, wait a minute, schedule, and should yield. If yes, it will request host callback. If no, it will run callback. Okay. Oh yeah, sorry. The scheduler, inside of scheduler, there's a work loop there. So basically, it says if the time is permits. If not permit, it will. Wait a minute. Should yield. Should yield means not permit. Yes. So it will go back again. So it loop has like event loop working all the time. If not yield, meaning there's time, then he run a task. So basically, this is how it works. And these posts from Web.dev explain something similar, but with more details on history. So let's just quickly go over through it. I think it's pretty useful. So what a task? Basically, if you run a function, it's a task. One thing to notice that, for example, this is from the profiler. When a task is initiated, everything inside of the function will be counted as one task, so there will be no stop in it. If a function say save settings have 5 inner functions to call, there will be no interruption, will be no stopping between these function calls, because everything here will be counted into one function. So if the task contains this function, this will be continuous action for that task. So basically, for each task, it will be, I think most of the time, it will be triggered by some event, if it is event handlers or network events, or something else. So for a task, there will be event handler, and there's a function inside of it. There's like 5 inner function here. So you can see there's no stop. So this is what it looks like. And because of this, this main thread thing, there's only one thread. Set aside other like worker stuff, and the UI update, the calculation, the network, all will be in this one timeline. You can see the timeline here, and obviously, if it is occupied, there is no time for the browser to update the UI. So you will sometimes feel the web. Sorry, I caught COVID. You will feel the UI feels janky, not responsive stuff. We already know that we can break it down by set timeout. This is kind of a nice trick, right? So for a bigger task, you can set timeout on each inner function, and it will possibly create something like this, because set timeout is an API for the host. So when you run set timeout, it will insert that task into the event loop. That will be a different task. It's not something inside of the task. And within this, the UI will have the opportunity to update the UI, for example, here, something like this. So yeah, here's the example. If you have some interactions here, event, the event loop will not break it down. You will append it to the event loop. So you can see it like a queue. It will just push something into the queue, and so there will be a huge delay, right? Possibly will be a huge delay between this event and the handler. You will feel like the janky, but now you can insert this thing inside in between those tasks, so it will be better. Cool. So yeah, so basically you can set timeout here like this. You say, okay, these two, because they are not user visible, save to database, and send analytics and low priority. So you can set a timeout and say, hey, you can do it later. And for this function, I want to make it as small as possible, so I keep these three. Cool. There's an example like for something like you handle a large chunk of data, like with a for loop. It means that you can possibly, but it will you can like break it down for every 100 items, stuff like that. But it will be problematic and difficult to implement. Maybe you want to have this data in integrity, right? You don't want some data to be processed, only part of it. You want the whole to be processed. Then it will be trickier to implement. Besides set timeout, we can use post message. I think I've already mentioned in another video about React internally for scheduler. It actually use the message channel. I think on top of this document, if you can see, set mediate event in. Where is it? Where is the event loop? Set mediate, set timeout, and yeah, I think it's post message. Oh, sorry, post message. Oh yeah, it says post message. Blah blah blah. And also there's a function called request idle callback. It would be useful if you want to do some send beacons analytics beacon, which is only low priority. So you can see that this is kind of tricky, right? Set timeout, it's not easier to write. Maybe you want to have some nested set timeout. In order to make it easier, you can wrap everything into a yield domain. It does nothing. It actually uses set timeout, but it returns a promise, which means that you can do something like this, right? So I have 5 tasks, and for each task, I will use a while loop just to loop over through them. And for when the task is run, I await the yield domain. It's basically the same as this one, but you can see that it is easier to understand the code. It basically, okay, I'll give up the control of the process for the main thread. You can handle it. This is much easier to use, as it says somewhere. It makes the function like a more declarative. If you write a set timeout, we need to wrap the stuff inside of it, right? Inside of it. It will make the code messy, but now it's just that we have this simpler call. You can add some if conditions here. If this task is do something, we yield. If not, it will be much easier to management. Okay, cool. So now after we break the task down, we can see there are 5 tasks, and now the waterfall looks something like this. It's much. There will be a stop between them. Yeah, you can see we can add some if condition here. If we need to handle user input, we yield. Otherwise, we don't. So maybe is input depending. I've also created a video about is input depending somewhere, I think, if you search on my channel. Yeah, and this piece of code is more similar to what I explained into the React UI, because there's a term called time slicing. React actually sets up 5 milliseconds. It's much smaller than 50 millisecond. So basically the logic here would be the same. So we check every time when we run the task to see if it still have time, the deadline, right? The deadline, every time we increment it with 50 millisecond, if we don't have time, then we yield, and it extends the timeline. Otherwise, we run the task. So this is a basic time implementation about the time slicing. Sorry, this COVID thing, it just bothers me. Cool. Anyway. Oh, I forgot. There was one thing I wanted to talk about. What is that? So, deadline. I'm not ready. Okay, let's continue. The gaps in current API is that there's no priority setting here actually. If we go to the React implementation on JSer.dev, you can see clearly that it's managed by a main heap. And the priority is controlled by the task. I think there are quite some priority here. Is set like immediate. This is the highest priority. And user blocking. We have the same naming. User blocking. Yep. And the normal priority, low priority, idle priority. There are 5 different priorities. These will be used to do the prioritizing in scheduler. Cool. So actually there's a new API. It's currently being developed. It's available on Chromium and Firefox under a flag. So post task, it's kind of like what we have in React here. Schedule callback with priority. It's the same. It allows us to set 3 kinds of priority, which is background, low priority, user visible is for medium, for user blocking is critical. I think the mapping would be user blocking. I think is the, let's see, what is it? Where is it? Wait a second. Yeah, here. Immediate priority means right now. So the default, because default is user visible, which means default user visible is normal priority, right? And the user blocking is actually user blocking plus the immediate priority. So this API doesn't have this differentiation. It's only treat this as one. This is normal, and this is the low priority. It only had 3 levels. So if we set settings, you will say scheduler post tasks, run it with high priority, user blocking, with the blocking. This one is low priority, and this is user blocking, high priority. This is background is low priority. So we can break it down something like this. But something interesting, if you take a look at the timeline, sorry, for the save to database is here, but it's scheduled actually the third one before update UI, but it has low priority, so you will be run after the update UI. See, so you can see that this is actually some heap structure that a priority queue. You can say is priority queue. Yeah, cool. But built-in yield with continuation, and now rather than the yield to main, we could use the scheduler yield. The scheduler yield is we've also covered it in this React actually. When the task is broken down, actually there will be a continuation here. I'm not sure whether it's explained in this document or not. Let's see. Continue. Yeah, here. No, not continue. Is input. Continuation callback. Yeah. Because in React, as we said, there will be a runtime to do the reconciliation, and that kind of work on each fiber node could be interrupted. When we run when it is interrupted, we'd like it to be continued for the next round of the task, right? If you can, the browser can take advantage of the interruption to do something with high priority, but after that, we should continue from the last time. That's what continuation callback is doing here. and this scheduler yield actually do the same. It is different from what we had for the yield to main method, because if you can take a look at this, if this default is long task, we input and render and set them out, stuff like this. With yielding, if we have some yield to main with set out, you say long task is broken into two, right? The chunk, and then we set them out. So input render allows the browser to do something to feel responsive, and the set timeout kicks in, and the next part of the task will be run, right? Because set timeout is called and then continuation. Oh, no. This set timeout is something different, I guess. Yeah, but with the scheduler yield, that the continuation, the tasks that are left out will be run immediately after it's ready. Yes, you can see that task execution picks up where it is left even after the yield point. I think yeah. Yield to the main thread. I think wait a minute. This is something interesting. Okay. Yield to main. Scheduler yield. Is it like we have the generator function? When we yield, we can continue from the when we next run it, it will continue from the last time, right? Where it is yielded. So actually, a way to schedule the yield, I think it is not within the scope of post task, not about the schedule itself, but rather it's a way to break a task, like here. Yeah, it is a way to break the task, not the scheduled part. You can run it with any function. It will be yielded, and then it will be immediately picked up after the input render stuff is done. So this is some other API, and post task is another API. So don't mess them up. I think they are totally different. Cool. I think that's it. So post tag is not supported. You can use some if you can use some polyfill. If you go to the documentation, I think it is clearly mentioned that it is wait a minute. I think this is it. No. Explainer. It is clearly mentioned that you see the idea. I think it is mentioned in the React concurrent mode. I think it's kind of inspired from that, or this is a collaborating effort. I don't know. But I just want to mention that the APIs provided described in this document is very similar to what React Scheduler does, and possibly when this built-in API is implemented in every browser, possibly React will switch from their implementation to the native implementation. And React has done a great job that the scheduler is actually a separate module, so they can just simply replace them. There might be some thing needs to be done in the mapping of these different parties, but yeah. And let's see if it's supported in browser. It's in Chrome, Edge, but yeah, Safari. Yeah, Safari is not supporting it. There's no signal on that, maybe. Let's see, go to the MDN, see if Safari has some signals on it. Safari, nope. Cool. Whew. All right, that's it for today. Hope it helps. It's a really interesting topic. And I'm surprised that actually what we've learned in React could be related to this topic. And to be honest, I don't think that in a day-to-day job we should use this API. It's very advanced API that possibly we don't need to do with them. If we are just writing normal web applications, this is pretty low level. I think it should be only used for frameworks like React or Vue or anything else. Okay, cool. Thanks for watching. Yeah, I'll put a link in the description. See you next time. Bye bye.